Hey guys, how's it going? Professor Brian back. Some more acid-base equilibria, specifically determining whether a compound, an ionic compound specifically, is going to be acidic, basic, or neutral, and how to determine that, looking at Ka's, looking at the molecule. So here we have a question. This is on the worksheet, acid-base solution equilibrium. This is going to be in the pretty sure this is in chapter 17, which is going to be additional aspects of aqueous equilibrium. So they ask a really good question here. Is sodium bicarbonate acidic, basic, or neutral? And you must show your work to justify your answer. So what they have done here is they've asked us, are we dealing with a neutral situation? Are we dealing with an acidic situation? Or are we dealing with a basic situation? So how do we go about determining all of that? And I am going to do that here. All right. So if we're dealing with sodium bicarb, the first thing that we need to be able to distinguish is whether it is an acid, a base, or neutral. And that involves looking at the different ions in solution. So if this is in fact soluble, which they tell us is aqueous, we are dealing with two aqueous ions, and we need to be able to look at each of these. Now, what do we know about sodium? We know that sodium is the ion associated with sodium hydroxide, which is a strong base. So we know that sodium is neutral. Sodium itself, ion, does not do anything in water from an acid-base perspective. However, we do know that HCO3 is the conjugate base of a weak acid, and technically it's the conjugate acid of a weak base. So what do I mean? I mean this is that bicarbonate can undergo two chemical reactions. So this is where we're talking about a polyprotic acid. So when we're dealing with polyprotic acids, we have to remember that the forward reaction of acidity and the reverse reaction of being a base can both occur. So when we're dealing with bicarb, we can have bicarb interact with water to create carbonic acid and hydroxide, or we can have carbonic interact with water and create carbonate and acid. Okay, and hydronium. So the question that they're really asking you here is this acidic or basic? But the way you need to think to be able to answer that is to say which one of these two reactions is favorable from a equilibrium perspective, meaning which one of these is more likely to happen. They have given us the Ka for H2CO3 and the Ka for HCO3 minus. So what they have done is they've given us the Ka here, and this will be called Ka2, and they tell us that this is equal to 4.8 times 10 to the negative 11, okay, which is relatively small, right? Which means we're dealing with a weak situation, okay, we're dealing with a weak situation. Now, to know the Ka of the Kb, the Kb for this, because this is a basic situation, right? We do see this. A, conjugate base, and this is bicarbonate as an acid. AB, conjugate B, conjugate A. So here it is acting as a base. Here it is acting as an acid. So we need to be able to relate the Ka of bicarb to the Kb of bicarb. And how can we determine that? Now, this is where we have to remember that the Ka times the Kb is equal to Kw always for a given molecule. Therefore, the Kb for our carbonate, or bicarb, is equal to Kw divided by the Ka of HCO3 minus, which we were given in the problem. So what is Kw? 1 times 10 to the negative 14. Ka, 4.8 times 10 to the negative 11. And therefore, Kb for the molecule we're interested in is equal to 1 to the negative 14 divided by 4.8 e to the negative 11. 2.08 times 10 to the negative 4. Okay, so what does that tell us, right? Being able to do the math doesn't matter unless you understand what this means. Remember, if equilibrium and the value of equilibrium, the smaller the equilibrium constant, the more products are formed. The larger the equilibrium constant, the more products are formed, which means the stronger of a forward reaction we're dealing with. So this value, Kb, is larger than Ka. So if Kb is greater than Ka, then the molecule will act as a base. And therefore, if the molecule acts as a base, then we should expect the dissolution of sodium bicarbonate to create a basic solution. So to go back to the question, is it acidic, basic, or neutral? It is in fact basic. And it is because Kb particularly is greater than Ka, which means that this reaction here will proceed forward and not the reverse reaction. So again, this is a great example of being able to determine for a polyprotic species, such as carbonic acid, which direction you expect the reaction to occur, and therefore how it will impact the pH. Again, if you have any questions, feel free to reach out, leave a comment.